Okay, hi everyone, welcome back to this evening's live stream for Windows Server 2003. So I just want to share my screen. Okay, monitoring and troubleshooting DNS. Now that you have set up and configured your DNS name server and created some resource records, you will want to confirm that it is resolving and replying to DNS requests. There are tools that allow you to do some basic monitoring and managing. Once you are able to monitor DNS, you'll want to start troubleshooting. The simplest way is to use the ping command to make sure the server is alive. A more exhaustive test would be to use NSLOOKUP to verify that you can actually resolve addresses for items on your DNS server. In the following sections, we'll look at some of these monitoring and management tools as well as how to troubleshoot DNS. Monitoring DNS with the DNS snap-in. You can use the DNS snap-in to do some basic server testing and monitoring. More importantly, you use the snap-in to monitor and set logging options. On the Event Logging tab of the Server Properties dialog box, you can pick which events you want logged. The more events you select, the more log information you'll get. This is very useful when you're trying to track what's happening with your servers, but it can result in a very, very large log file if you're not careful. So you can see here, figure 6.13, the Event Logging tab of the Server Properties dialog box. The Monitoring tab gives you some testing tools. A simple query against this DNS server asks for a single record from the local DNS server. It's useful for verifying that the DNS service is running and listening to queries, but not much else. The A recursive query to other DNS servers test is more sophisticated, using a recursive query to see whether forwarding is working okay. The Test Now button and the Perform Automatic Testing at the following interval control allows you to run these tests now or later as you require. So figure 6.14, the Monitoring tab of the Server's Properties dialog box. So we can see here, so exercise 6.5, simple DNS testing. So 1, open the DNS management snap-in by selecting Start Administrative Tools, DNS. 2, right-click the DNS server you want to test and select Properties. 3, switch to the Debug Logging tab. Check all the debug logging options except filter packets by IP address, and enter a full path and file name in the file path and the name field. Click the Apply button. 4, switch to the Monitoring tab and check both a simple query against this DNS server or a recursive query to other DNS servers. 5, click the Test Now button several times and then click OK. 6, using Windows Explorer, navigate to the folder that you specified in step 3 and use Word to view the contents of the log file. Monitoring DNS servers with System Monitor. After you install the DNS service, you will be able to select the DNS object in the Windows Server 2003 System Monitor. This object contains many different counters that are related to monitoring DNS server performance and usage. So using the System Monitor, you can generate statistics on the following types of information: AXFR requests, all zone transfer requests, IXFR requests, incremental zone transfer requests, DNS server memory usage, dynamic updates, DNS notify events, recursive queries, TCP and UDP statistics, wins statistics, zone transfer issues. All of this information can be analyzed easily using the chart, histogram, or report views of the System Monitor. Additionally, you can use the alerts function to automatically notify you or the system administrators whenever certain performance statistic thresholds are exceeded. For example, if the total number of recursive queries is very high, you might want to be notified so you can examine the situation. Finally, information from performance logs and alerts can be stored to a log data file. So monitoring DNS events in the Event Monitor. By default, Windows Server 2003 automatically logs DNS events in the event log under the distinct DNS server heading. Conveniently, the DNS snap-in contains a copy of the DNS event log so that you don't have to switch out the utility to view the log. Table 6.4 lists some of the more common events. So I'll just go through these here. Event and description. 2. The DNS server has started. This message generally appears at startup when either the server computer is started or the DNS server service is manually started. 3. The DNS server has shut down. This message generally appears when either the server computer is shut down or the DNS server service is stopped manually. 414. The server computer currently has no primary DNS suffix configured. Its DNS name is currently a single label host name. For example, its currently configured name is host rather than host.example.microsoft.com or another fully qualified name. 708. The DNS server did not detect any zones of either primary or secondary type. It will run as a caching-only server, but will not be authoritative for any zones. 3150. The DNS server wrote a new version of zone name to file name. You can view the new version number by clicking the Records Data tab. This event should appear only if the DNS server is configured to operate as a root server. 6527. Zone name expired before it could obtain a successful zone transfer or update from a master server acting as its source for the zone. The zone has been shut down. Monitoring DNS in Replication Monitor. As you saw earlier, ADI zones do not use traditional zone transfers. Instead, they are replicated along with the other Active Directory information. To diagnose ADI zone replication errors, you should look at AD replication itself. Windows Server 2003 does not include support for AD replication monitoring. By default, you must install the support tools included on the Windows Server 2003 CD in order to run the replication monitor utility as shown in exercise 6.6. So installing and running replication monitor. 1. In Windows Explorer, navigate to /support/tools/folder on the Windows Server 2003 CD. 2. Double-click the support subtools.msi file that appears in the folder. 3. The Support Tools installation wizard guides you through the installation process. To ensure smooth operation of the support tools, be sure to install them to the default directory. 4. After the installation is complete, you can run the replication monitor by selecting Start Run and entering REPLMON in the Run dialog box. The replication monitor window is shown in figure 6.15. When you first start replication monitor, the window is empty. You must manually add servers to monitor, as you will see in exercise 6.7. In the figure, you can see that a server has already been added. The individual components of Active Directory are displayed under the server name. So you can see here, figure 6.15, the replication monitor window. The two most practical uses for replication monitor are viewing failed replications and manually initiating replication between domain controllers. If you find that DNS information is not synchronized between servers, you can be sure that replication failed at some point due to any number of reasons, usually a router failure between sites. Replication Monitor will tell you exactly when the replication failed. If you notice a failure and replication isn't scheduled to occur soon, you should manually initiate replication to get those DNS updates immediately. So exercise 6.7 shows you how to add one or more servers to the replication monitor, check for replication failure and initiate replication manually. Working with replication monitor. So 1, open the replication monitor by selecting start run, the entering repel mon in the run dialog box. 2, to add a server to the replication monitor window, right click monitored servers and select add monitored server from the pop-up menu. 3, the add monitored server wizard appears. Select either add the server explicitly by name or search the Active Directory for the server to add. If you choose the latter option, you must specify a domain to search in the list of domains. Click next when you are done. 4, depending on the option you choose in the previous step, you will be prompted to either enter a server name or choose a server from a list. In either case, enter or choose the server to monitor and click finish. To search for replication errors, click the action menu and select domain. Search domain controllers for replication errors. 6, the search domain controllers for replication failure window appears. Click the run search button, enter the name of the domain to search. After a few moments, replication monitor should list any failures in the search domain controllers for replication failures window. Click close. 7, you can manually synchronize either the entire Active Directory or just individual pieces. In order to synchronize the domain DNS zones, only right-click the DC equals domain DNS zones, DC equals domain, DC equals suffix item under the monitored server and select synchronize this directory partition with all servers from the pop-up menu. 8, depending on how your domain is configured, you can choose to disable transitive replication, push mode, or cross-site boundaries checkboxes. In this case, leave them blank and click OK. 9, you will be prompted to confirm the replication. Click yes. 10, click OK at the success notification. Troubleshooting DNS. When troubleshooting DNS problems, ask yourself the following basic questions. What application is failing? What works? What doesn't work? If the is the problem basic IP connectivity, or is it name resolution? If the problem is name resolution, does the failing application use NetBIOS names, DNS names, or host names? How are things that do and don't work related? Have the things that don't work ever worked on this computer or network? If so, what has changed since they last worked? Windows Server 2003 provides several useful tools that can help you answer these questions. This section discusses the following tools: NSLookup, which is used to perform DNS queries and to examine the contents of zone files on local and remote servers; IPconfig, which is used to view DNS client settings, display and flush the resolver cache, and force a dynamic update client to register its DNS records. The DNS log file, which monitors certain DNS server events and logs them for your edification. NSLookup. NSLookup is a standard command line tool provided in most DNS server implementations, including Windows Server 2003. It offers the ability to perform query testing of DNS servers and to obtain detailed responses at the command prompt. This information can be useful for diagnosing and solving name resolution problems, for verifying that resource records are added or updated correctly in a zone, and for debugging other server-related problems. You can also do a number of useful things with NSLOOKUP. Use it in non-authoritative mode to look up a single piece of data, enter interactive mode and use the debug feature. Perform the following from within interactive mode. Set options for your query, look up a name, look up records in a zone, perform zone transfers, exit NSLOOKUP. Let's start using NSLOOKUP in plain old command line mode. NSLOOKUP name server. This code will look up a DNS name or address name named using a server at an IP address specified by server. However, NSLOOKUP is a lot more useful in interactive mode because you can enter several commands in sequence. Running NSLOOKUP by itself without specifying a query or server puts it in interactive mode, where it will stay until you type exit and press enter. Before that point, you can look up lots of useful stuff. While in interactive mode, you can use the set command to configure how the resolver will carry out queries. Table 6.5 shows a few of the options available with set. So option purpose set all shows all the options available with the set option. Set D2 puts NSLOOKUP in debug mode so you can examine and query the response packets between the resolver and the server. Set domain equals domain name tells the resolver what domain name to append for unqualified queries. Set timeout equals timeout tells the resolver which timeout to use. This option is useful for slow links where queries frequently time out and the wait time must be lengthened. Set time record time tells the resolver which type of resource records to search for example, A, PTR, or SRV. If you want the resolver to query for all resource records, type set type equals all. While in interactive mode, you can look up a name just by typing it. Name server. In this example, name is the owner name for the record you are looking for, and server is the server that you want to query. You can use the wildcard character star in your query. For example, if you want to look for all resource records that have K as the first letter, just type K as your query. If you want to query for a particular type of record, for instance, an MX record, use the set type command. Set type equals MX. This example tells NSLOOKUP that you're only interested in seeing MX records that meet your search criteria. There are a couple of other things you can do with NSLOOKUP. You can get a list of contents of an entire domain with ls commands. To find all the hosts in the apple.com domain, you'd type set type equals A and then type ls-t apple.com. You can also simulate zone transfers by using the ls command with the -d switch. This can help you determine whether or not the server you are querying allows zone transfers to your computer. To do this, type the following: ls-d domain name. A successful NSLOOKUP response looks like this. So you can see here server name underscore, so name underscore of underscore DNS of server address, IP underscore address underscore of underscore DNS underscore server, response underscore data. NSLOOKUP might also return an error. The following message means that the resolver did not locate a PTR resource record containing the host name for the server IP address. NSLOOKUP can still query the DNS server, and the DNS server can still answer queries. So you can see here, the following message means that the request timed out. This might happen, for example, if the DNS service was not running on the DNS server that is authoritative for the name, so request to server timed out. The following message means that the server is not receiving requests on UDP port 53. Server can't find name underscore or underscore IP underscore address underscore queried underscore for no response from server. If the DNS server wasn't able to find the name of IP address in the authoritative domain, you'd get the following message: server can't find name underscore or underscore IP underscore address underscore queried underscore for non-existent domain. The authoritative domain might be on the remote DNS server or on another DNS server that this server is able to reach. The following message generally means that the DNS server is running but is not working properly. Server can't find name underscore or underscore IP address underscore queried underscore for server failed. For example, it might include a corrupted packet, or the zone in which you are querying for a record might be paused. However, this message can also be returned if the client queries for a host in a domain for which the DNS server is not authoritative and the DNS server cannot contact its root servers, or it is not connected to the internet, or it has no routines. Exercise 6.8, you'll get some hands-on practice with the NSLOOKUP tool. So using the NSLOOKUP command, open a Windows Server 2003 command prompt by selecting Start, All Programs, Accessories, type command prompt. Type NSLOOKUP and press the Enter key. For the rest of this exercise, use the Enter key to terminate each command. NSLOOKUP will start displaying a message that tells you the name and IP address of the default DNS server. Write these down, you'll need them later. Try looking up a well-named address. Type www.microsoft.com. Notice that the query returns several IP addresses. Microsoft load balances web traffic by using multiple servers in the same DNS record. 5. Try looking up a non-existent host. Type www.fubijar.com. Notice that your server complains that it can't find the address. This is normal behavior. 6. Change the server to a non-existent host. Try making up a private IP address that you know isn't a DNS server on your network, like 10.10.10.10. Do this by typing server IP address. NSLOOKUP will try to turn the IP address into a host name. Eventually, it will display a message telling you that the new default server is using the IP address you specified. Try doing another lookup of a known DNS name. Type www.microsoft.com. Notice that NSLOOKUP is contacting the server you specified, and that lookup times out after a few seconds. 8. Reset your server to the original address you wrote down in step 3. 9. If doing so won't disrupt your network, unplug your computer from your network and repeat steps 4 and 8. Notice the difference in behavior. Using ipconfig, you can use the command line tool ipconfig to view your DNS client settings, to view and reset cached information used locally for resolving DNS name queries, and to register the resource records for a dynamic update client. If you use the ipconfig command with no parameters, it displays DNS information for each adapter, including the domain name and DNS servers used for that adapter. Table 6.6 shows some command line options available with ipconfig. So command, what does it do? ipconfig/all displays additional information about DNS, including FQDN and the DNS suffix search list. ipconfig/flush DNS flushes and resets the DNS resolver cache. For more information about this option, see the section configuring DNS server earlier in this chapter. ipconfig/display DNS displays the contents of the DNS resolver cache. ipconfig/registrations refreshes all DHCP leases and registers any related DNS names. This option is available only on Windows 2000 and newer computers that run the DHCP client service. Using the DNS log file, you can configure the DNS server to create a log file that records the following information: queries, notification messages from other servers, dynamic updates, content of the questions section for DNS query messages, content of the answer section for DNS query messages, number of queries this server sends, number of queries this server has received, number of DNS requests received over a UDP port, number of DNS requests received over a TCP port, number of full packets sent by the server, number of packets written through by the server and back to the zone. The DNS log appears in system root /system32 /DNS/DNS.log. Because the log is in RTF format, you must use Word or Word to view it. You can change the directory of the file name in which the DNS log appears by adding the following entry to the registry with the reg_sz data type: h_local_machine /system /current control set /services /DNS /parameters /log file path. Set the value of log file path equal to the name of the file and path where you want to locate the DNS log. By default, the maximum log file size of DNS log is 4 MB. If you want to change the size, add the following entry to the registry with the reg_dword data type. So you can see here, set the value of the log file max size equal to the desired size file in bits. The minimum size is 64 KB. Once the log file reaches the maximum size, Windows Server 2003 writes over the beginning of the file. If you make the value higher, data persists for a longer time, but the log file consumes more disk space. If you make the value smaller, the log file uses less disk space, but the data persists for a shorter time. So that's it for this chapter. So we're going to leave it here this evening for Server 2000 live stream, and have a nice evening.